Welcome back. So the question is, a child stands at the center of a turntable with his two arms outstretched. The turntable is set rotating with an angular speed of 40 revolutions per minute. How much is the angular speed of the child if he folds his hands back and thereby reduces his moment of inertia to 2 by 5 times the initial value? Assume that the turntable rotates without friction. So we are given with the initial angular speed and the relation between the momentum inertia of both the cases. Here we can use conservation of angular momentum as no external force is acting the system. So we can write I1 omega 1 equals I2 omega 2. So omega 2 is equal to I1 omega 1 divided by I2, and the value of omega 1 is given, that is 40 revolutions per minute, and I2, we write the I2 as 2 by 5 times the initial value, which is capital I. So it gives us the value of 100 revolution per minute. So that the child's new kinetic energy of rotation is more than the initial kinetic energy of rotation, how do we account for this increase in kinetic energy? The final and initial velocities are given below, as EF equals half I2 omega 2 square and EI equals half I1 omega 1 square. Taking the ratio of both, we get EF by EI as half I2 omega 2 square divided by half I1 omega 1 square, which is giving the value of 2.5. Thus the final energy is 2.5 times the initial energy. The increase in energy is due to the internal energy of the boy.